Lesson 10.4, Common Logarithms. If you use your calculators to take the log of 6, it would give you approximately 0.778. Take the log of 0.35, you get negative 0.456. We talked about how we have, all of a sudden, how can we have a negative power? Well, remember, we're asking ourselves 10 to what power gives us 0.35. Well, that's pretty small. It's also a fraction. So this power must have been negative, which means we would have 10 or 1 over 10 to the negative power we end up having. And because it's a fraction, because the power is negative, it creates a fraction. And that's how we get decimals like this. Now we are using logarithms on our calculator that are in base 10. And we can't do any other type of problem besides base 10. So if we look at this question and change it from exponential notation to logarithmic, we get log base 5 of 62 equals x. And the changing of notation in this case doesn't help us any, like it did in previous lessons. So here's where we learn the true power of logarithms. I'm going to take the log of both sides. And with this, we can use one of the three properties that come with logarithms, and that is that we can take the exponent and bring it out to the front of the logarithm, which will give us x log 5 equals log 62. And log 5 is a number, and we can calculate the answer of x by dividing both sides by log of 5. So x equals, if you divide those two, you get approximately 2.56. So yeah, the next one we would do the same way. Take the log of both sides, which allows us to take the variable and bring it out in front. And again, we can solve by dividing both sides by log 3. And x will equal about 2.58. Now be careful when you punch this in your calculator that you're typing in log 17 and it has parentheses there. You actually close off the parentheses before you do division. Otherwise it'll accidentally throw in 17 divided by log 3 in for the first log. It will mess it all up. So if you end up with getting the wrong answer, check this parenthesis, make sure it's in. Okay, so the true power of logarithms is really, I think, to access a variable in the exponent position, whereas before we really had no way of getting to it. But if you take the log of both sides, you now have access to that variable in a power position. It also leads us to the rule of how to handle logarithms that are not base 10. Here we have a log of base 5. The calculator can't do it. But your calculator can do log of 12 divided by log of 5. And your calculators are in base 10 for this, and you can get an answer. So this one would be done by taking log of 20 and dividing by the log of 2. So we can actually use our calculators to do these questions. So it's not actually calculating base 2, but it is using log base 10 to do the calculations, in the formula that is. And this one would be log 18 divided by log 3. which would give us about 2.6309. Alright, now, two more questions here. If we apply the log question here, or the log approach, we would take log of 2 to the 7x power greater than log of 3 to the 5x minus 3 power. Again, we have the ability to take the powers out of the power position and bring them to the forefront, which will give us 7x log 2 greater than parentheses 5x minus 3 log 3. Now, here's where I want you to calculate out what these numbers are, because we want to actually use the numbers. Let's use 4 decimal places would work. So if we take log of 2 times 7, we would get 2.1072x. I would basically take log 2 times 7 greater than, and if we calculate log 3 and distribute it, we would get 2.3856x minus 1.4314. And now we can combine like terms by bringing this over through subtraction, which would give us negative 0.2784x greater than negative 1.4314. We divide by negative 0.2784, we'll get x is, and because we divide by a negative, the inequality will change directions, and you get 5.14. Now, all of the decimals we used to represent logs were in 4 decimal places. Our answer can be 2. We want to make sure we have enough decimals to eliminate round-off error. Our next one, same idea. Log both sides, and we'll get 3x log of 5 after we apply the property to bring down the exponent. And we'll get parentheses x minus 2 log 10. Now log 10 is 1, so that's a handy one. Log of 5 times 3 is 2.0969x. Less than x minus 2. We add, oops, excuse me, that's not what I want to do. I want to subtract x from both sides, bring my like terms together. That will give us 1.0969 less than negative 2. Divide both sides by 0.0969, and we get x. And we divide by a positive, so the inequality doesn't change. We get negative 1.8233. Okay, so we have our 2 solutions. And with inequalities, it's best to calculate the log out into a decimal, because log of, for example, log of a small number, let's say log of 0.5, is negative. And if you divide by log of 0.5 and not realize it's negative, then you would forget to change the inequality direction. So it's best to change it to a decimal. I recommend changing it to a decimal and calculating it with numbers like you would anything else. And then you'd be more likely to notice whether or not you have a negative and that you're dividing by 1. And this ends lesson 10.4.